The sun is unlimited and the cleanest source of energy apart from wind and water. Depending on the latitude, from 600 kilowatt-hours to 2,500 kilowatt-hours of solar energy per square meter per year reaches the Earth's surface. This is the average monthly energy consumption of a house. It is estimated that the energy of all existing coal, oil, and gas deposits equals the solar energy which reaches the Earth within 56 days. It is less than 2 months. Currently, up to 0.02% of this energy is used. Solar energy is obtained through solar panels, where the absorbent agent, for example water, is heated, or through conversion into electricity in photovoltaic cells. Photovoltaic cells make use of photoelectric effect to produce electricity. There are 2 types of photoelectric effect: external and internal. External photoelectric effect occurs with the emission of electrons from a physical body upon exposure to electromagnetic radiation, for example, light. In the internal photoelectric effect, electromagnetic radiation results in transferring electrons between electronic bands of an atom. Observing this phenomenon leads to the following conclusions. The number of emitted electrons is directly proportional to intensity of radiation. For every substance, there is a border wave frequency below which the phenomenon does not occur. Kinetic energy of the emitted electrons does not depend on intensity, but only on the frequency of light. The photoelectric effect was discovered by Heinrich Hertz in 1887, but it was Albert Einstein who explained it, and he was awarded the Nobel Prize in 1921 for this work. Einstein assumed that light consists of particles, photons, and that their energy is directly proportional to wave frequency. EF equals hv, where v is the frequency of light and h is the Planck constant. Work function W is the minimum energy required to remove an electron from a solid, therefore kinetic energy of the ejected electron equals the energy of the photon, less the work function AK equals hv minus W. So the photoelectric effect is directly applicable in producing electricity from the sun. The photoelectric effect occurs in photovoltaic cells, which are simply light-emitting diodes with a large surface. Right now, the photovoltaic market is dominated by silicon panels, but silicon is not the best optoelectronic material as it poorly absorbs light. However, it is cheap, the technology is well known, and its market share is 90%. The alternative are the so-called thin-film solar cells, which use copper indium gallium diselenide or cadmium telluride and can be 100 times thinner than silicon cells. The photoelectric effect in photovoltaic cells involves generating an electron-hole pair by a photon striking a semiconductor. An electron-hole pair is a negative charge, an electron, and a positive charge, for example, a hole. In semiconductor junctions, there is a very thin area, 1/1,000,000th of a meter, which has a very strong electric field, with intensity of up to millions of volts per meter. If an electron-hole pair enters this area, it will be separated, dissociated, and the carriers will be pushed outside. If they enter an electrical circuit, the current will flow, and we can use this electrical power in everyday life.